Hello, welcome back to FCS 424. We are in Chapter 4 on carbohydrates in sport and fitness. The learning objectives for this chapter are posted in Moodle. Be able to classify carbohydrates according to their chemical composition. For example, mono, di, and polysaccharides. Those are just 3 examples. Describe the digestion and absorption of carbohydrates. Be able to explain the metabolism of glucose, which we talked about in chapters 2 and 3. Describe how muscle glycogen and blood glucose are used to fuel exercise. Detail and explain carbohydrate recommendations for athletes, including specific guidelines for intake before, during, and after exercise. And be able to determine the daily carbohydrate needs of an athlete and select carbohydrate-containing foods to meet the recommended intake. So, a fun and informative chapter. First section is an overview of carbohydrates in food and provides the opportunity for you to familiarize yourself with terminology. Take a minute and see if you can match these 4 items on the left with these definitions on the right. More than one definition can belong to a single term. So, carbon, hydrogen, oxygen is most closely associated with the definition that reads carbohydrates that are often abbreviated to CHO and represent the atoms or elements contained within carbohydrates. B, sugar, is represented by both A and C. So sugar provides only energy, not vitamins, minerals, or fiber, and provides energy at 4 kilocalories or calories, which I'll use synonymously with gram per gram. C, starch, provides energy at 4 calories per gram. And D, cellulose, is found in starchy foods, provides no energy, and E is a type of fiber. Carbohydrates in food continues here with some fill in the blank. And the last question on here asks you to, the last sentence asks you to select whether you can or cannot. So we'll get to that. Number 1, carbohydrates are found in a wide variety of foods and classified as monosaccharides, disaccharides, or polysaccharides. Saccharide means, okay, you said sugar or sugar unit, you're correct. Number 2, list the 3 monosaccharides found in food. If you said glucose, fructose, and galactose, you're correct. Number 3, list the 3 disaccharides found in food. They include lactose, sucrose, and maltose. Number 4, fiber is you can say carbohydrate. I would like you to say polysaccharide, and it's the structural component of plants. Human enzymes can or cannot break down fiber. The answer is cannot. Your first objective can be answered by referring to this table in your textbook, which characterizes monosaccharides. Glucose, fructose, and galactose are the important monosaccharides that are included in nutrition. Glucose has a glycemic index of 100, meaning that it will stimulate your blood sugar and insulin more than any other carbohydrate. Glucose is said to be about 75% as sweet as table sugar. Most carbohydrates will be converted into glucose. The monosaccharide fructose is found temporarily in the liver before being converted into glucose. You can see the glycemic index is 19, which means that it does not stimulate an insulin response as high as glucose does. Fructose is an ingredient in high fructose corn syrup. Galactose is found only as part of lactose. It's not very sweet at all, and it has an unknown glycemic index. The chemical structure of the monosaccharides, glucose, galactose, and fructose, show that each one of these contains 6 carbons. In terms of carbohydrate sweetness, sucrose, a disaccharide composed of glucose and fructose, is given the value 100. The other mono and disaccharides are compared in terms of sweetness to sucrose. Sucrose is found in maple sugar, honey, fruits, vegetables. Wherever it's found, every gram of carbohydrate contains 4 kilocalories. Here are the chemical structures of the disaccharides. This is the chemical structure of glycogen. Glycogen is a series of glucose molecules. There's no single way to classify carbohydrates. There are a number of ways in which carbohydrates are classified. Sugars versus starches. So the sugars would include mono and disaccharides, while the starches include polysaccharides. Simple versus complex carbohydrates, where the simple carbohydrates are monosaccharides and disaccharides, and the complex carbohydrates are polysaccharides. So be aware of the different ways in which carbohydrate can be defined, especially when you're asked in quizzes and exams. Minimally processed carbohydrates are associated with a higher quality of food versus carbohydrates that are highly processed, like cakes you buy out of the box. They tend to be not as healthy. Be able to define or identify definitions for digestion, absorption, the small intestine, and enzymes. On this slide, you can match these 4 definitions with the terms, or definitions, I should say, that are listed here. Carbohydrate digestion begins in the mouth. Salivary amylase is secreted by our salivary glands. Salivary amylase begins the breakdown of carbohydrate into smaller chains. The pancreas is also responsible for secreting an enzyme that digests carbohydrates. Pancreatic amylase is secreted directly into the small intestine in response to carbohydrate ingestion. Fibers do not get broken down by human digestive enzymes. Instead, fibers are fermented to some extent in the colon. There is some energy that is released when fiber is fermented, and this can be used as an energy source for the colon. This picture from your text shows the lumen of the small intestine. When it is magnified, you can see these finger-like structures called villi. You will call from FCS 342 that villi increase absorptive area in the small intestine and allow your small intestine to have the absorptive surface area of a tennis court, approximately. On top of villi are microvilli, and they further increase surface area. The digestion and absorption of carbohydrate is illustrated here in this top picture. Green shows the dietary carbohydrates that we can consume. Starch is broken down into glucose in our body with the help of the enzymes salivary amylase and pancreatic amylase. The disaccharides lactose, maltose, and sucrose are broken down by enzymes that are specific to breaking these disaccharides down. They line the small intestine, specifically the brush border of the small intestine. Lactase breaks down lactose, maltase breaks down maltose, and sucrase breaks down sucrose into their component monosaccharides. See if you can select the incorrect answer here in regards to metabolism of glucose in the body. Is it A, homeostasis of blood glucose concentration is within a fairly narrow range? Is it B, insulin is released after eating a carbohydrate-containing meal? C, insulin stimulates the storage of amino acids, fat, and glucose? Or D, glucagon is released after a carbohydrate-containing meal? The answer is D. D is incorrect. Glucagon and insulin are counter-regulatory hormones. Insulin is released in response to a carbohydrate-containing meal, and glucagon is released in response to low levels of blood sugar. This is an excellent chart on your book that shows the regulation of resting blood glucose levels. On the y-axis, you see the glucose level, which ranges from low to high. There's a green area that indicates the normal range, which is estimated to be between 60 and 110. On the x-axis, you see the amount of time after a meal. So in the first white text box, you see the stressor, which is they call it a stressor in here, eating carbohydrates. So your blood glucose levels will increase in response to that stressor. At a certain point, the pancreas will be stimulated, specifically beta cells of the pancreas, and they will release insulin. Insulin is a hormone that signals the body to store glucose. Not only glucose, but also amino acids and fat. Insulin also stimulates the muscles and the liver to store glucose as glycogen. So a number of things happen. As blood glucose levels drop over time, levels can fall out of range in response to fasting. In response to fasting, glucagon is produced. Specifically, the alpha cells of the pancreas are stimulated to release glucagon. Glucagon's jobs include the stimulation of the mobilization of amino acids and fat. So it tells your body to release amino acids and fat, stimulates gluconeogenesis, which is the production of glucose, and also stimulates the liver to release stored glucose, which is called glycogenolysis. When glucose is gotten from glycogen, it is referred to as glycogenolysis. So insulin and glucagon are counter-regulatory and work to put your body back into a nice, normal, happy glucose range. The results of a study in which subjects were given 50 grams of carbohydrate and either unsweetened applesauce, which is considered a low glycemic index food, or 50 grams of carbohydrate from orange juice, which is considered a moderate glycemic index food. You can see the blood glucose response for orange juice is higher than that of applesauce. So it is recommended that low glycemic index foods be consumed to help regulate blood glucose. The glycemic index does have some limitations though, however, but they can point in the direction of a healthy carbohydrate. Which statement is true about the glycemic index? Is it A? Foods with a low glycemic index include white bread, cornflakes, and baked potatoes. Is it B? High glycemic index foods cause a rapid rise in blood glucose levels followed by a rapid rise in insulin. Or is it C? High glycemic index foods including legumes, beans, and fruits and non-starchy vegetables. Or D, an athlete may want to consume low glycemic index food after a workout to synthesize muscle glycogen quickly. The answer is B. The only true statement here is that high glycemic index foods cause a rapid rise in blood glucose levels followed by a rapid rise in insulin. You've seen this picture in the previous chapter. It shows the metabolism of glucose or glycogen being broken down into pyruvate and glycolysis. During conditions in which oxygen is low, pyruvate can be converted into lactate. Lactate is a metabolic compound that can be used as an energy source for some of your higher aerobic organs like your heart. Too much of an acid in your bloodstream, however, can lead to acidic conditions. This graph from your textbook shows the results of a study that analyzed the amount of muscle glycogen in subjects who were exposed to high-intensity 15-minute intervals of cycling. Subjects repeated 15 minutes of exercise, and after 60 minutes, muscle glycogen was so depleted it was difficult to continue. So you can easily deplete your muscle glycogen with high-intensity exercise. Here's another little exercise that asks you to select the incorrect answer of the 4 choices listed here. On the right are the results of a study that looked at how carbohydrate intake during exercise affected ability to perform. On the y-axis, you see the amount of muscle glycogen in the muscle obtained using muscle biopsies. On the x-axis, you see the time from 0 hours to 4 hours, so pretty long stretch. The study was done in cyclists who were riding at a very high intensity. Within the graph, you see a red line and a blue line. The red line represents carbohydrate, the group of cyclists who ingested carbohydrate during their activity. The blue line represents cyclists in a group who did not ingest carbohydrate during this period of time instead ingested a placebo. You can see that the blue line, which is the placebo, containing no carbohydrate, resulted in the group being less likely to last for the duration of this activity. You see the blue line stops at 3 hours. Okay, so armed with this information and with the information that you have read in chapter 4, which one of these is the incorrect answer? A, exercise has a strong insulin-like effect, meaning exercise can stimulate glucose uptake from the blood. B, glycogenolysis is the release of glucose from glycogen caused by glucagon. C, fueling with carbohydrate during exercise is detrimental to performance. Or D, muscle glycogen utilization is no different when athletes consume a carbohydrate drink compared to a placebo drink during high-intensity activity. The answer is C. Fueling with carbohydrate during exercise can increase the duration to which you can exercise. During exercise, the body is under a certain amount of stress. Normal physiological stress response results in the release of neurotransmitters such as epinephrine and norepinephrine and cortisol that help to regulate energy use. However, prolonged stress or excess stress, when underfueled, will lead to the breakdown of protein, and your body will not rebuild that protein. So keep that in mind. While this is the normal physiological stress response to exercise stress, don't be one of the individuals who underconsume calories and protein and put yourself under exercise stress. It is not healthy. The estimates for daily carbohydrate intake are included in a number of graphs in your textbook. The minimum daily carbohydrate recommendation is 3 grams for every kilogram of body weight. Daily carbohydrate recommendations can increase to 12 grams per kilogram of body weight, dependent on intensity and duration of activities. This is a comparison of 2 individuals on a 70% carbohydrate diet. Jennifer consumes 2,000 calories a day and consumes about 70% of her energy from carbohydrate, while Liza consumes 1,400 calories with 70% of her energy intake from carbohydrate. After all of the math is laid out, we see that based on the total carbohydrates taken in by each of these individuals, Jennifer is getting 6.4 grams for every kilogram body weight, while Liza is getting 4.5 grams for every kilogram body weight. So dependent on the activities that Jennifer and Liza are participating in, that's going to determine whether this is enough carbohydrate. Okay, the next few slides show carbohydrate recommendations during exercise. This particular table shows examples of some products marketed to athletes for pre-exercise training. The recommended carbohydrate intake to enhance performance depends on the type of activity in which you're participating, how long it lasts. There are recommended carbohydrate intakes based on exercise intensity and duration. In order to maximize the rate at which glycogen is replaced, it is recommended that you consume a carbohydrate-containing meal within 1 hour of exercising. Consuming protein with that meal can also help to replenish glycogen. And refueling with carbohydrate, it's recommended that sucrose or glucose be used in these. This may be one of the only times where a high glycemic index food may be recommended within the hour after you exercise to improve muscle glycogen synthesis. Carbohydrate loading can help increase the amount of glycogen an athlete or person can store in his or her muscle. An example of a carbohydrate loading protocol from your textbook is figure 4.26, which shows you the classical carbohydrate loading protocol. In this 7-day protocol, on days 1, 4, and 7, exercising to exhaustion is done. Days 2 and 3 involve a lower carbohydrate diet, about 5 grams per kilogram of body weight per day, while days 4 through 7 advise a high carbohydrate diet. This is the loading period of about 8 grams per kilogram of body weight per day. There is a carbohydrate loading protocol called the modified carb loading protocol. In the depletion stage, days 1 through 3, it is recommended that the diet consist of 5 grams of carbohydrate for every kilogram body weight, coupled with exercise in order to exhaust or deplete glycogen stores. Days 4 through 6 are the loading period in which carbohydrates are consumed at a rate of 10 grams of carbohydrate per kilogram of body weight during the repletion stage. See if you can answer these fill-in-the-blank questions. Number 1, carbohydrate loading is a technique that can maximize blank stores. Number 2, the classic protocol increases stores from approximately 100 to 125 millimoles per kilogram. This is glycogen to levels approaching blank millimoles per kilogram. This method has several blanks during the depletion and repletion stages. So number 1, carbohydrate loading is a technique that can maximize glycogen stores. Number 2, the classic carbohydrate loading protocol increases stores from approximately 100 to 125 millimoles per kilogram to levels approaching 210 millimoles per kilogram. This method has several side effects during the depletion and repletion stages. Irritability is a possible side effect, also inability to complete exercise intervals, and possibly hypoglycemia. Number 3, during the depletion stage of the modified protocol, blank grams per kilogram of carbohydrate are consumed. The repletion stage calls for a carbohydrate intake of blank grams per kilogram. The modified protocol allows for supercompensation of blank millimoles per kilogram. So number 3, during the depletion stage of the modified protocol, 5 grams of kilogram of carbohydrate are consumed. In the repletion stage, 10 grams per kilogram of carbohydrate. The modified protocol allows for carbohydrate loading, also known as supercompensation, of 205 millimoles per kilogram. The modified carbohydrate loading protocol avoids some of the side effects associated with the classic loading protocol. This illustrates the decline of muscle glycogen with successive days of training. Before and after, subjects completed 10-mile runs on a treadmill for 3 consecutive days. This textbook contains a number of useful tables to help guide your eating patterns. This table is 4.10 and it allows you to estimate daily carbohydrate you need in grams based on your body weight. It gives you weight in pounds and weight in kilograms. And you can look at your carbohydrate level ranging from 5 to 10 grams per kilogram of body weight and get a range of the number of grams of carbohydrate it's recommended you consume per day. Some people use carbohydrate counting or exchange lists to help keep track of the number of carbohydrates they need. In this example, a 135-pound female weighs 61.3 kilograms and is at a carbohydrate level of 5 grams per kilogram of body weight. This rounds to approximately 307. Within exchange lists, carbohydrate servings are grouped into increments of 15 grams of carbohydrate. So in order to determine the number of carb servings that are allowed, you can take the number of grams allowed daily, divide them by 15, and get the number of carb servings, which can be rounded. There are a number of resources that list the amount of carbohydrate by food and serving size. In this particular slide, I added in a column that shows you carb servings. If you're using exchange lists or carb counting, the carb equivalents are listed here in this 4th column. So in order to get the number of carb servings, you would take the grams of carbohydrate that's in a food divided by 15, and you would get the number of carb servings approximate. Here's the starch list continued. Also, you can see a couple more columns that indicate whether food is whole grain or gluten-free. Here are some fruit servings with carbohydrate grams listed and also number of grams of fiber. It's important to consider practical issues surrounding food. I know it may seem simple and some of it's common sense, but there are some things that we can be more mindful of. For example, the storage of certain items to keep them fresher longer. You're going to need to be eating regularly. So some tips are included here from your textbook. Acesulfame potassium contains the mineral potassium. It is often mixed with other artificial sweeteners like aspartame. Aspartame is a controversial non-nutritive sweetener. Sold as equal and NutraSweet. It's made up of 2 amino acids, aspartic acid and phenylalanine. Phenylalanine cannot be properly metabolized by some people who have a syndrome called phenylketonuria, abbreviated PKU. Some individuals are sensitive to aspartame and have experienced symptoms such as headaches, memory loss, mood change, seizures. However, aspartame is FDA approved and there are cut points for safety based on body weight. Saccharin is the oldest artificial sweetener. It was once taken off the market based on research that linked it to bladder cancer in lab studies. Stevia is derived from an herb that has sweet tasting leaves. It may also have a beneficial effect on blood and insulin levels, blood glucose and insulin levels. Okay, some questions. Lactose intolerance, fermentable fibers, or carbohydrates, I should say, and gluten intolerance. Number 1, lactose malabsorption occurs when there is inefficient relative to lactose consumed. That's the answer, folks. Okay, lactase. You said lactase, you're correct. The results of lactose malabsorption are gas, bloating, diarrhea, nausea, abdominal pain, and is a condition that is called lactose intolerance. Fermentable carbohydrates are blank blank carbohydrates that sometimes cause GI upset. Collectively, this group of carbohydrates are labeled. Okay, fermentable carbohydrates are short-chain carbohydrates that sometimes cause gastrointestinal upset. Collectively, this group of carbohydrates are labeled FODMAPs. Gluten is a mixture of proteins, and celiac disease is when the immune system responds to gluten and causes chronic inflammation of the small intestine. FODMAP is the acronym for fermentable oligo, di, and monosaccharides and polyols. Oligo means medium chain, di means two chain, and mono means singular. So there are oligo, di, and mono sugar units, and also a chemical formation known as polyols. In summary, carbohydrates are the primary energy source for moderate to intense exercise. Exercise will reduce glycogen stores. These stores must be replenished on a daily basis, so it's important to consume carbohydrate at regular intervals. Find a way to keep track, in the beginning if you're first starting out, and then you get the hang of it and you won't have to think about following good food habits so much. Your practices will become second nature. The general recommendation for carbohydrate intake for athletes is training. In training is 3 to 12 grams of carbohydrate for every kilogram of body weight daily. A method endurance athletes and some bodybuilders use is carbohydrate loading. Healthy carbohydrate choices are the basis of a healthful diet and important in athletic training. It's important to consume sufficient amounts of carbohydrate and pay attention to timing and also the nutrients that you're consuming along with the carbohydrate. The type of carbohydrate that you choose after a workout also will influence glycogen synthesis. Some athletes will have lactose intolerance, reactive hypoglycemia, or diabetes, and these conditions influence the choice of carbohydrate-containing foods. Let me know if you have any questions from this chapter.